This is the question that we left you with yesterday to work on for homework here. We have 4 vectors that we're adding together, 10 meters, 5 meters, 3 meters, and 5 meters. We add them together as scalars. We want to find the total distance traveled. The distance traveled would simply be 10 plus 5 plus 3 plus 5 is 23 meters. But if we add them together as vectors and we want to find the displacement, then it becomes trickier because we have to account for the direction. And the direction is not just as simple as, oh, one's north and one's south. We got a south, and then we got a north, and we got an east, and we got a north of east, and it becomes trickier, right? We have to break these up into x and y components. We have to, x and y components. Even before we do that, because we have a funny angle, we always, when we see a funny angle in any context, including this one, say 5 words. I don't like funny angles, right? I don't like funny angles. So we got to get rid of it. Okay, we get rid of the funny angle. We take it off to the side over here, label the 30 degrees right here, label the 5.0 meters right here, and then we resolve it into x and y. I like to do it in blue and green, just so that we're consistent and we keep good structure here, but it doesn't really matter if you're in different colors or whatever. Now, if I'm looking for the x component of this, how much of this 5 meters is x and how much of it's y, which trig function would I use? What side of the triangle is x? Opposite, adjacent, or hypotenuse? It's adjacent. And I have the hypotenuse, right? So adjacent and hypotenuse would go with which trig function, Scott? Adjacent and hypotenuse, it would be what? Right, so ka toa. So we're going to say cosine 30 degrees is equal to adjacent over 5.0. X is equal to 5.0 times cosine 33, which is 4.33. What is it after that? 01? 4.3301 meters. Now, let's find the y component. It's the opposite side. We have the hypotenuse. So let's say sine 30 degrees is equal to opposite over hypotenuse. That's going to be exactly 2.5 meters. As you know, I like to kind of box it off because that's what makes this question a little bit different from the other ones. Now, what I want to do is get out the Photoshop and Photoshop that guy right out of the picture. And now we just have all nice lines, right? All nice arrows pointing along one axis or another. Now is when I have to break it up into x and y components. Here's x, here's my y column. What's the x component of the first one, the 10? Jordan, what's the x component of that first one? 0. What's the y component of that first one? Negative 10, good. Negative because it's down, right? Good. Ashley, what's the x component of the next one, the 5 meters? Good. Positive? Yep. And what's the y component? Good. Rochelle, what's the x component of the next one, the 3 meters? Good. And the y component is? Yeah, is it positive? Yep, because it's upwards. Kind of erase that arrow, but it's important to have those arrows on there, right, so that we can see whether it's positive or negative. What about the next one, that 5 meter last one that I photoshopped out? Okay, Carissa, what about that one? What's the x component of that one? Good. Is it positive? Yeah, because it's to the right. And what's the y component? Good, and it's positive as well because it's up, right? So we add these up. 5 plus 4.3301 gives me 9.3301. And negative 10 plus 0 plus 3 plus 2.5 gives me, I think it's 4.5, isn't it? Negative 4.5? Now we redraw it. Now we redraw it, right? We say 9.3301. How do I know to make that right? How did I know to make that to the right? Yeah, it's positive. It's the x-axis and it's positive. Now, 4.5 negative is downward, right, for the y component? Where do I draw that? Right here? Why not? What's wrong with that one? Has to be head to tail. When we're adding vectors together, and that's really what I'm doing, is adding these two vectors together, it has to be drawn head to tail. So that doesn't work. How about this one? Does that work? No, how come? That's head to head. Has to be drawn head to tail. How about this one right here? There are a couple of options. Does this one work? Yeah, that one does. That's drawn head to tail. Now, if I do that, my resultant vector would be drawn like this. Is that right? It's not drawn head to tail, though. That's head to head and tail to tail. Is that okay? Yeah, the head to tail rule only applies to the vectors we're adding together, not the resultant vector, not the sum of them. So we're going to label this as R. You could label it as delta D with the arrow over it, the displacement, right? I'll label it as R, the resultant vector, and I'll label theta in position 1, 2, or 3. Where is it? Position 1, 2, or 3? 1, because that's at the start of the vector diagram, right? R is equal to the square root of 9.3301 squared plus 4.5 squared. Let's get that. Let's say second function square root, use some brackets here, 9.3301 squared plus 4.5 squared, and that bracket as well. We get 10. Two significant digits, it would be 10 meters. And theta is the inverse tan of opposite over adjacent. What's opposite, 9 or 4.5 here? Ella, what's the opposite side, 9 or 4.5? Yep, so we're going to say 4.5 over 9.3301. Some people ask, well, what about the negative 4.5? Once I put it into this diagram, the arrow shows the direction. I don't need to worry about the negative for anything here once I'm defining the resultant vector. Okay, only in your components. All right, let's do this. What should we do on our calculator before we do this? Sine 90, just to make sure, right? First time today. Sine 90 is 1. Okay, we're good to go. Nobody's switched our calculators into radian mode. If they have, well, then you've got to fix it. Let's say the inverse tan of 4.5 over 9.3301 gives me 26 degrees. Now, this is what we started doing for the first time yesterday. 26 degrees measured from where? Where am I measuring that angle from? Okay, north, south, east, west. Where's the angle being measured from here? From the what? From the east. Okay, but it's not only is it east, it's south and east, right? Which one do I list first? It's measured from the east, but south from the east. So we're going to call it south from east or south of east. Yes, 26 degrees south of east. Now, how many people got that? Okay, anybody draw it the other way, like this? If you do it like that, that's fine, right? But the angle that you would have gotten wouldn't have been 26 degrees. It should have been 64 degrees. Did you guys get 64? Okay. How would you express that? 64 degrees east of south, because then you'd be measuring it from the south, right? But yet it's east from the south. Both of those are correct. Remember what I told you yesterday? My position right now is 2 meters from this wall. It's 8 meters from that wall. Well, both of those mean the same thing, right? 64 degrees east of south, 26 degrees south of east. Both of those mean the same thing. Good. All right. Let's do another example here. Oops, that's not where it is though. Let's do another example, but this one, I have 2 more examples actually, but these 2 are going to involve word problems where we haven't drawn the vector diagram for you already. It doesn't change things much, really doesn't, but it does a little bit. You should have these examples already in your notes. Question 15 says, find the sum of the following vectors. I could have also asked this in another way. I could have said, find the total displacement. I could have also said, add the following vectors. All of those would have meant the same thing. Find the sum of the vectors, add the vectors, find the total displacement. They all mean the same thing. If I had said, find the total distance traveled, that'd be a bit different, because distance is a scalar. Distance traveled would be 100 plus 50 plus 20 plus 30 is 200 meters. Distance would just be 200. Easy, right? But displacement or adding the vectors, or finding the sum of the vectors, that's a little bit harder. But not too bad here, because we don't have any funny angles. Let's add these together. I'm going to say 100 meters to the west. Now I got 50 meters to the south. Where am I going to draw that? Well, it doesn't really matter as long as you draw it head to tail. This works. But could I have drawn the 50 then the 100? Sure. If you're adding scalars, what's 1 plus 2? What's 1 plus 2? Exactly. What's 2 plus 1? Okay, it doesn't matter what order you add scalars. It doesn't matter what order you add vectors either. So even if I reverse the order of these, it wouldn't make any difference. Then we get 20 meters to the east. Let's draw that like this. Is that okay so far? Head to tail, right? 30 meters to the north. Is that okay? Yeah, that's good. Everything's drawn head to tail. Might not be to a perfect scale. You want to draw it as best as possible to scale, but I'm not asking you to take a ruler out to draw it to scale, okay? The resultant vector goes right here, is that right? Yeah, that's right, from start to finish, tail to tail, head to head. That's okay because it's the resultant, it's the sum of the vectors. That's what we're solving for is R. Now, I don't have to deal with funny angles because I don't have any funny angles, but I still have to deal with X and Y. The X component of the first one is, this is easy now, right? Like we've done crazier questions than this. Negative 100 and 0, 0 and neg 50, 20 and 0, and 0 and 30. Add them up, negative 80, negative 20. We're going to say 80 this way, 20 down. And my resultant vector, by the way, I drew my arrows, right? It's important to draw your arrows. My resultant vector goes from start to finish. And my resultant vector looks the same, go figure. I don't need to worry about the negatives on there now, right? Now that I draw my diagram. R is the square root of 20 squared plus 80 squared. Gives me 82. Where am I going to label my angle position? 1, 2, or 3? Where is it, Emily? Yeah, position 3. And it's going to be the inverse tan function. It's always the inverse tan function, right? Of opposite over adjacent. What's opposite, 80 or 20? Nick, what's opposite, 80 or 20? 20, yeah. The inverse tan of 20 over 80. We don't need to do that check again because we already have. Gives me a value of 14 degrees. If you had drawn it the other way, you would have gotten 76 degrees, right? This would be 14 degrees what of what? And then I'll answer your question. 14 degrees what of what? This would be south of west. Yeah. We're measuring it from the west. The angle is measured from the west axis, but yet it's going south from the west. So south of west. Emily, question? No, absolutely not. If you included the negative sign right here, you got to be really careful with that. If you do, technically you're squaring a negative becomes a positive, but sometimes we don't use brackets correctly, and you end up squaring the positive and just making the term negative. So I would highly recommend that you leave out the negatives here, even though technically it should work. Okay, it leads to a mistake a lot. Okay, and right here, you could put the negative in. It just would have given us negative 14 degrees. Okay, you just drop the negative with your answer. Honestly, it's easier just when you're doing this stuff just to drop the negatives right off the top. Good? Not bad, eh? Okay, next one, let's draw this one together, and then I'll have you guys solve this one yourself once we draw it as a group. Doesn't matter what order we do it in, but we might as well do it in the order that it's given to us here. 10 kilometers east. 20 kilometers south of east. South and east is going to be down this way, right? right? Where do I label that 30 degrees? Is it here or is it here? Position 1 or position 2? Where do I label the 30 degrees? If I label it position 2, that would be measured from the south, right? If I labeled it down here, my angle would be measured from that south axis right here. That's not what I want. I want it from the east, of the east. So I'm going to label it up here. Does that make sense? That's the tricky part of this question right there, is to label that angle in the proper spot. From the east, of the east, but yet south from the east, or south of the east. And then we got a 15 south. And it's going to look like this. My resultant vector goes from here to here, is that right? No? A couple of people shaking their heads, no? It's opposite direction, good. Goes from start to finish, right? Tail to tail, head to head. If we do it the other way, it's just going around in this big circle. Okay, see what you can do with that one for the next few minutes here in class. And then we'll move on. Let's have a look at this, guys. We have a funny angle here, 30 degrees south of east. We got to take that off to the side. Let's do that right now over here. Okay, here's my 30 degrees right here. Here's my 20 kilometers. Let's label this as X, and let's label this as Y. Let's find the X component using the cosine function, because it's the adjacent side. 20 times cosine 30 degrees is 17.32. Keep going, 17.32 what? 3205, okay. And the Y component, using the sine function, that's going to be just 10 kilometers. Now, let's box that off. Let's box that off. And then let's replace this 20 meters, get rid of it completely. Let's replace it with a 17 over this way. And a 10 this way. And now we're going to say X's and Y's. We're going to say 10, 0, 17.3205, and negative 10 for the second vector. Does that make sense? For the third vector, 0 and negative 15. 27.3205 and negative 25. 27.3205, 25 down this way. And our resultant vector is going to go from start to finish. Theta is going to be drawn right here. What's the value of R going to be there? Anybody have that? Square root of 27 squared plus 25 squared? 37. Now, whoops, not 37 degrees, 37 kilometers. Now, we would expect the angle here to be fairly close to 45, right? 27 and 25. Could be a little bit more than 45 or a little bit less than 45. A little bit less, because we went over more than we went down, right? What does it work out to be? I'm going to guess 43. 43? The inverse tan of 25 over 27. What is that? 43 degrees south of east or east of south? South of east. Okay, it's measured from the east. This is the east. It's measured from the east. South from the east. Or south of east, we're going to call it. Good.